Designers can achieve big reductions in the embodied carbon in buildings. Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer, is talking with in-house experts about how they're reducing the effect of buildings on climate change. Here's how Embodied Carbon is a production of Thornton Tomasetti.
Hi, and welcome to episode 6 of Here's How Embodied Carbon. This series explores how engineers and designers can reduce embodied carbon. That's the emissions associated with building materials, and thereby minimize the negative impacts of buildings and other structures on climate change. I'm Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer. We're an international, multidisciplinary engineering and consulting firm. We've been focused on embodied carbon for over a decade and are channeling all of our capabilities to tackle climate change. I'm talking with technical experts from across the company about the paths they are taking to achieve the greatest reductions in greenhouse gas emissions on their projects. Today, I'm talking with my colleague, Erin Gallagher, a sustainability consultant who guides project teams through materials credits and other aspects of achieving LEED certification. We're discussing environmental product declarations, or EPDs, which are used in LEED certification to account for embodied carbon. Hi, Erin.
Hi, Amy. Thanks for inviting me to help demystify the use of EPDs. Once you're used to using these informational documents, it becomes as easy as saying your ABCs.
We do love our acronyms in the sustainability design community, don't we? They roll off the tongue, but what do they really mean and how do we use them?
There are some 3-letter acronyms that come in handy when we talk about trying to reduce embodied carbon in a building or product. An LCA, or life cycle assessment, is a way to assess the entire environmental impact of a product or building. An LCA for a building material would start with raw material extraction and assess its environmental impacts all the way to the end of its life.
But isn't this podcast about another 3-letter acronym, the EPD? Can you tell us what EPDs are?
Yeah. So life cycle stages in an LCA are coded and defined by ISO 14040 and 14044, which is a widely accepted international standard that provides guidance and normalization. The stages are separated into 4 main phases, A, B, C, and D. A covers material extraction, manufacture, and transport. Stage B is use and operation. Stage C is for waste and demolition, and Stage D is for recovery. And each one gets broken down into more detail, so A1 covers impacts from raw material extraction, A2 covers transportation of materials to a manufacturing plant, and A3 covers the manufacturing processes. Life cycle assessments can be cradle-to-gate or cradle-to-grave. Cradle-to-gate assessments only look at the upfront supply chain emissions. That's the A1 through A3 sections. Cradle-to-grave covers everything in a cradle-to-gate assessment and adds the emissions from construction, operation, demolition, and sometimes end of life, which might mean disposal or recycling depending on the material. Cradle-to-gate is more limited than cradle-to-grave, but it's often more reliable because we're not making assumptions about what's happening during operation or end of life for the product or the building. There's a time and place for both.
So you're saying that if we want to understand the real environmental impacts of a product, we should conduct an LCA. Because embodied carbon is measured by a product's life cycle impacts and not just its energy use in the here and now, LCA is a really useful tool. But isn't this podcast about another 3-letter acronym, the EPD? Can you tell us what EPDs are?
An EPD is an environmental product declaration. It's essentially an LCA of a specific product. It's a document that quantifies the environmental impacts of a unit amount of a product. They're generally provided by a third party and are about 20 pages long. The environmental impacts assessed can vary, but most EPDs will include categories outlined by TRACHE, which is the EPA tool for reduction and assessment of chemicals and other environmental impacts. The categories include stratospheric, ozone depletion, acidification, eutrophication, formation of the tropospheric ozone layer, depletion of non-renewable energy sources, and then the one closely linked to embodied carbon, global warming. There are different types of EPDs. The two we talk about the most are product-specific EPDs and industry-wide EPDs. The product-specific EPD is pretty much exactly what it sounds like. It covers data from a specific manufacturing plant for a specific product. An industry-wide EPD covers data from multiple manufacturers and multiple products. These ones are really useful for benchmarking and seeing where an industry is at for a given material. Then there are also group EPDs, which fall in between. They typically cover multiple products that are similar, but from one company.
An EPD seems like a useful guide for diving deep into just one product or a type of product. What's in an EPD that makes it so helpful? I'm the kind of person who skims instruction manuals until I find the page with the pictures. So please tell me how to get to the best stuff in an EPD fast.
When looking at any EPD, you'll see a lot of general information about the product. One thing that's important to look for is the date of issue and the period of validity to make sure that your document hasn't expired. This information can usually be found in the first few pages of the EPD, along with its scope and whether or not it's third-party verified. If it's an industry-wide EPD, it will also list the contributing members, who are the companies and manufacturers that are trying to move the needle on carbon by providing data. The declared unit is another essential part of an EPD. A life cycle assessment is done for a particular unit of the material that the EPD is for. So for steel and aluminum, we often see the declared unit being per unit mass, but for concrete, this is often per unit volume. This is important to know if you have to do any unit conversions. An EPD will also contain specific technical details about the material. For concrete mix EPDs, for example, you'll see information about whether it's normal weight or lightweight, its strength, and how many, if any, supplementary cementitious materials are in the mix.
Yeah, I could see all this stuff being useful, but where do I go to get the information on global warming? The LCA category that you said is linked to embodied carbon.
The heart and soul of an EPD is an LCA summary table. It's where the numbers are. It lists environmental impact categories and breaks out results by life cycle stage. And the units used to measure each of the categories are normalized to a particular molecule of concern. For example, GWP, which is global warming potential, measures all greenhouse gases, but the unit is kilograms of carbon dioxide equivalent. It basically measures the impacts of all greenhouse gases and translates them into the amount of carbon dioxide that would create the same amount of warming. So 1 kilogram of CO2 has a GWP of 1. Methane, on the other hand, can trap the same amount of heat as 25 kilograms of CO2. So 1 kilogram of methane has a GWP of 25 kilograms of carbon dioxide equivalent. I'll add that you can measure GWP over different time periods since gases break down in the atmosphere at different rates, but it's standard to measure GWP over a 100-year period.
The LEAD program requires a certain number of products in a project to have EPDs, so it's good to know what an EPD is. But what if the project aims to reduce embodied carbon?
A lot of our clients have been asking us to claim carbon savings through EPDs. And using EC3, which is a tool from the Building Transparency nonprofit, which calculates embodied carbon in construction, is a really good way to do that. It's free, it's available online, and very easy to use, and it has a database of hundreds and hundreds of EPDs. You can do whole building assessments in EC3, or you can do material by material research tasks.
Geez, another 3-letter acronym. Well, I guess it's really 2 letters and a number.
Yes. So when you make your free account and get into EC3, you'll see a list of different options. If you're a manufacturer, you could add EPDs to the database, or if you're a designer, you may want to find and compare materials. In EC3, there are many different material categories that you can look at. If you do a search on concrete EPDs, for example, EC3 lets you adjust your search parameters so you can keep it as broad or as narrow as you want. For concrete, these parameters include compressive strength, curing time, and cement type. You'll nearly always want to narrow down where it's produced since the data varies a lot by region. And EC3 lets you narrow your search down to a specific state. When you run your search in EC3, the tool will perform a statistical analysis of all the data points that came up in your search and will present them as a box plot diagram. This is a visual representation of the spread of the data points that appeared in your search. The tool will provide the highest global warming potential, the lowest global warming potential, and then the interquartile range. Statistically, this range is the spread between the 25th and the 75th percentiles, but it's also just a fancy way of saying it's where most of the data points lie. Using the EC3 tool is a useful way to get a good view of where a product or a manufacturer falls relative to the rest of the industry.
Perfect. Choosing a product through looking at its EPD means a lot more if you can compare lots of EPDs. What if you're not sure what products are available?
You can also browse through all the products in the database. If you see one you're interested in, you can get details about that product and put its data point into the box plot so you can visualize where it falls relative to the statistical average. There's a lot more you can do with EC3, so I highly recommend everyone gives it a try. It's easy once you've gotten the hang of it, and you'll find that EPDs can be a very useful tool in designing for lower embodied carbon.
Erin, thank you so much for joining me, AMY, for this journey through the alphabet soup of LCA, EPD, and EC3. So it's simple. LCAs produce EPDs, which can be found using EC3. Folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.